Welcome to the tutorial on lesson 5.3, Factoring Trinomials. There's two parts to this video, and you are watching part 1. By the end of this lesson, you will be able to factor trinomials, and we're going to look at some steps and ways to do that. First, let's review the terminology involved in this section. The first term that we're going to look at is factor. A factor is any number or variable that when multiplied with one or more other numbers or variables forms a product. Let's look at a couple of examples. The first one is, what are the factors of 12? So factors can also be found by thinking about division and thinking about what numbers 12 is all divisible by. So of course 1 is our first number that all numbers are divisible by, so it's always a factor. 12 is also divisible by 2, by 3, by 4, by 6, and by itself, 12. So now we have all the factors of 12. 1 and 12 can be multiplied together to get 12. 2 and 6 multiply to get 12, and so do 3 and 4. What about the next example, a squared b? We want to write down all the things that are multiplied together to get this a squared b. A squared means a times itself. So there's two factors that are a and then just one b. So a squared b has three factors, a, and b. Alright, so now we're going to do an investigation using the trinomial x squared plus 6x plus 8. And we're going to use algebra tiles to model that trinomial by creating a rectangle with that many tiles. We're going to use one x squared tile, and we're going to use 6 x tiles and 8 ones tiles. And I'm going to draw my model starting with my x squared tile on this grid. We start with the x squared tile shaded in because we're going to be using positives, and then we start filling in the x tiles around it. So we start on one on the right side and one on the bottom, filling in the square with a ones tile. So now that polynomial would be x squared plus 2x plus 1. So we got to keep going. We need more x tiles. Let's put in another x tile right here and another 1. So now we have 3 x tiles and 2 ones. I think we need a few more. So I'm going to go ahead and fill some more in. And now I have 4 by and 2 x squared or x tiles, sorry. So that fills in another 8, or a total of 8 ones tiles. So I've made a rectangle out of my tiles, like an area of a rectangle. So then in the next step, number 2 here, I have to draw tiles along one of the lengths and one of the widths of the rectangle to model its dimensions. And that's why I drew this little grid here. We have to lay tiles along the edges of this grid so that they match up with the dimensions of our area. So on the width here, I drew in an x tile because it matches with the x side length of x squared, the x squared tile, and 2 ones tiles that match up with that edge length of the x tiles. Along the length on the top, I need to draw an x tile, and then I need 4 ones tiles to match up with those columns. And that gives me the tiles along the dimensions. What are those dimensions as polynomials? Well, we've got along the length, we've got an x and plus 4 ones. So the binomial would be x plus 4. And along the width, we have an x plus 2 tiles. So the binomial would be x plus 2. Now for step 4, let's look at multiplying those two dimensions or those two binomials out. So you have x plus 2 times x plus 4. And some of you might recognize the acronym FOIL. That represents the steps that you use to multiply out binomials. You have first times first, outside times outside, inside times inside, and last times last. It's just an acronym to help you remember those steps. Every term in the first polynomial gets multiplied by every term in the second polynomial. X times x gives you x squared. X times 4 is plus 4x. 2 times x is plus 2x. And 2 times 4 is plus 8. If we gather and combine like terms there, we have x squared, and 4x plus 2x is plus 6x, and then plus 8 on the end. And we look at our multiplication here, our trinomial is actually equivalent to the trinomial that we started with, that we modeled with an area of a rectangle. Remember, area of a rectangle is equal to length times width, and length and width end up being the dimensions or the factors of area. So to wrap up our investigation on the previous slide, let's look at factoring a trinomial with a model, kind of important points. So a rectangle can have an area that is a trinomial. By finding the dimensions of the rectangle, you are reversing the process of multiplying two binomials. The process is called factoring. That factoring is the reverse of multiplying. There's two steps. Step 1, you want to model the trinomial as a rectangle. Whenever you're trying to factor a trinomial using a model of algebra tiles, model that trinomial as the rectangle. Then find the dimensions of that rectangle. The length and the width are the factors of the trinomial. If we look at a couple of quick examples, x squared plus 5x plus 4, we want to draw that trinomial as a rectangle area. Start with your x squared tile and then fill in your x tiles around it. Finish off by adding in your ones tiles. Then your dimensions are the length and the width of that rectangle. So we fill in our width here with an x and a 1 to match the dimensions. And then we have an x and 4 ones to make up the length of our rectangle. So the factored form of x squared plus 5x plus 4 is x plus 1 and x plus 4. The second example involves factoring x squared plus 4x plus 6. Start with drawing your x squared tile and shade it in because it's positive. Then we're going to fill in 4x tiles around that. So let's start with 1 on the side and 1 on the bottom. If we fill in one single tile, that completes a square, but that only gives us 2x tiles and one single tile. So let's go with another x tile on the side and another one on the bottom. That'll give us 3 more ones tiles, but we still only have 4. We need to add 2 more ones tiles somehow, but we can't add any more x tiles. Because there's no possible way to do that, we already have all the x tiles we need, and we can't include these last 2 in a rectangle. This trinomial, x squared plus 4x plus 6, is not factorable using the model.